Everyone. Uh, Today we are organized a webinar on LNG regasification plant utility source. And today we are being joined by our guest speaker, Ms. Priya Singh, for this 1 hour webinar session. She has graduated from a UTU Maliba campus in 2008 with 9.5 CGPA and a nominee of the university medalist. And currently she is servicing in Shell Energy India, an oil and gas company, and the plant is located at Hazira, Surat. Thank you so much, Priya ma'am. Here I am welcoming to in our webinar session.
Thank you, Kritika. Thank you, ma'am and sir, and thank you everybody for such a lovely introduction. Hello.
Thank
Following the legacy, am I audible? Am I visible? Please let me know if there is any glitches in between.
you are audible and you are visible, ma'am.
Okay. Thank you, ma'am. So, yeah, first of all, I'm extremely sorry for being late. For as such, there was some technical issues and wasn't able to share the screen, wasn't able to hear my voice as well, and hear your voice. So, yeah, finally, when we have started the session, should I start sharing my screen directly, or is like something late being going on because I can't see other people joined? Have everyone joined over here?
Yes, ma'am. You continue.
Okay. So yeah, hello everyone. This is Priya, and such a lovely introduction given by Kritika ma'am. Thank you, ma'am, for the introduction. And already I have apologized for being late. Let's not delay it further and skipping straight to the point. Today I'm gonna share my. I'm just sharing my screen. Today I'm going to take a webinar on LNG regasification plant utility source. Since is my screen visible? Hello.
Yes, ma'am. Yes, ma'am.
Okay.
Your screen
Uh,
is visible.
okay. So since Kritika ma'am already informed about me, I'm working in a LNG regasification plant at Shell Hazira, a global venture of Shell Global located at European Union. And LNG regasification plant is located at Hazira, Surat. Okay. Now, I have charted out some topics for the same for today's webinar. You can have a glimpse over here. What is a LNG regasification plant? What is utility source? What is the source over here at this plant? Alternator, or you can say a gas turbine generator. Its advantages, and yes, actually, I kept an example video as in summary, but I don't think the time will permit us. So, s- skipping straight to the point, here I start the presentation with officially the first slide, which shows a sneak peek about the LNG plant. Now, as you all have might learned about the natural gas that is being dug from, that is the byproduct of petroleum. It is a renewable source of energy, and as we all know, like in future, with the initiative of government cutting the carbon emission to 50% to going it to leading it to 100% cut, we all are going to somehow use the renewable energy in our futures. Renewable energy is our future, we can say, to a point. So natural gas, it is being liquefied, so it is called as the liquefied natural gas. It is liquefied to 1/600th of the volume of natural gas, and it is liquefied so that it can be stored easily, it can be transported easily. As you can see in the image, natural gas, it is being dug at some point, it is converted, it is processed into liquefaction, and then it is stored and transported to a plant where it can be regasified, liquid say gas banana. All right. So yeah, this is the first thing, where LNG is converted into natural gas to liquefied natural gas. Now, here at Hazira, the LNG regasification plant is having some utility source, as such, like everyone is having, like every plant is having. Now, what is utility source? As you might have heard, like you might have having the knowledge of utility source is something that we utilize to have a facility, to provide a facility. So it can be an electricity, a natural gas, chilled water, steam, or any kind of external energy. Like every other plant, this plant is also having its own utility source, that is again a substation over here. Now the substation generates its own power, and the power is generated from the natural gas that is already available. So, since the plant is a LNG regasification plant, a substantial amount of natural gas is already available, and we can readily utilize it in the best manner to generate an electricity. Here comes into the picture the use of the knowledge that we have learned. Everybody knows what is natural gas, everybody knows what is LNG, everybody knows that every plant is having its own substation. But here comes the use of this knowledge, that okay, a substation, a plant can use its own, can generate its own electricity through the byproduct or through the residue that is already available with them. So it is possible, it is utilizing the possible ways and an optimum way to get the best out of what is already available. Since I think I'm clear, okay. And moving ahead, the utilizing or j- unused gas in the most optimum utility source of the plant here is the natural gas itself. I have created a block diagram which can represent this theory in the best manner. Am I audible?
Yes,
Hello?
ma'am. Yes, ma'am. Yes, ma'am.
Okay, sure. So please let me know in between if any glitches or any audibility issues are found. Okay, all right. So here is a block diagram to represent the theory. Since I have been working over here since past 3 years, uh, I can share the limited knowledge that I have gained through this block diagram in the best possible manner I have tried. So the liquefied natural gas is brought to the plant through an LNG jetty. As you can see, the boat type of structure I have tried to make. This is the jetty. Just may liquefied natural gas is being brought. From this liquefied natural gas, the natural gas is taken to the tanks and it processes through the all processed plant equipments and machines. It goes to the compressor, to the vacuum boiler, BOG, and everything, which is called as the LNG regasification process, put in the square box. And I have also written that this is the LNG process plant. From the LNG process plant, liquefied natural gas gets converted into the natural gas, and the natural gas is kept as the final product. Now, this natural gas is domesticated to the domestic users, to the petrol pump, sorry, to the pumps, to the stations, and as well as to the Pan India supply. Here, it is supplied not only to India, but I would like to keep it this note to the notice that it is also supplied abroad through the integrated pipeline structure. The unused natural gas. Now, what is this unused natural gas? This is nothing but the boil off gas, the natural gas that cannot be used. This natural gas is used or reused in the gas turbine generator. And using this gas turbine generator, the electricity is produced. This electricity can be reused in the LNG regasification process area. So whatever the machines, the plants, and everything that requires the power is being generated, it's being drawn with this GTG. Is it clear? I hope I am clear with everything. Coming to the next, alternator or the gas turbine generator. So I have tried over here some to keep some photographs to let it look real, and not just what generators we have been learning since 12th or in our college, yeah, of course, during the college days. So yeah, everybody knows what is a synchronous generator. This the basic principle we have been learning since our 12th or 10th classes, so I don't think I need to go much deeper into that, but of course I would like to brief about this. And synchronous generator or alternator, it converts the mechanical power into the electrical AC power, as simple as that, and as per the name's suggestion. It can be, of course, a single phase or a three phase, but due to many technical and commercial advantages, three-phase power is always produced. And of course, in 70 percentages of industrial usage, induction motors and this generators are being used due to its commercial and its industrial technical advantages. Moving next, working principle and construction of alternator. So, it works on the principle of electromagnetic induction given by Faraday, which states that current is induced in the conductor if the conductor placed in a magnetic field have a relative motion with respect to the magnetic field. So, of course, it is again something that we have learned in our 10th and 12th classes, the Fleming's thumb rule, or I could say the as per the Fleming thumbs rule, but the Fleming's thumbs rule is applied after the Faraday's law of electromagnetic induction. When a conductor is placed in a magnetic field, or when the magnetic field cuts the conductor, current is induced in the conductor. As simple as that. And this, with this basic principle, such a big task and such a big amount of generation of electricity can be done. It is just unimaginable. But yeah, that's true. Such a big boon to us by Faraday, sir. And the construction and working principle can be explained, it is self-explanatory through the below pictures. As you can see, the first image shows the working principle of an alternator, where two magnets with two poles are kept and there is a conductor in between. The conductor, when rotates, it cuts the magnetic flux that is produced between the two magnets, and as the conductor cuts the magnetic flux, a current is induced in this. As simple as that. And the second picture imbibes here is a construction. Yeah, it is the construction of an alternator. Since I've been using my mobile, I can't zoom it to that extent, or else the pixels will get blurred. But yeah, it is self-explanatory. Just like the working principle, there are two major aspects of constructions. First is the stator part and another is the rotor part. Where in rotor, there are, again, on basis of the rotor, there are two classifications, that is the non-salient pole construction and the salient pole construction. This could be, I guess, for the students of such an early age, won't be easy to grab in. They might be learning in their further stages of like third or fourth year, but yeah, that's okay for the initial beginnings. The stator part is having a winding, field winding, and the rotor part. The rotor, as it is seen in working principle, the rotor is a conductor, a bunch of copper conductors uh, in the slot of a rotating shaft, and as they cut the magnetic flux produced by the field winding, current is induced in them. It's such as simple as that. Now I have kept a block diagram which represents this theory. Now, for the generator, a prime mover is required. Here, the prime mover is gas turbine in LNG plant. Now, because the prime mover is gas turbine, the intake here is the gas, or the natural gas. And here comes into the picture the natural gas that I was telling about, unused or reused. This natural gas is taken as from outlet, and here it gets compressed in order to increase the pressure. It increases its heat, and the heated natural gas is it's pumped into this gas turbine, which in turn rotates the rotor, and which in turn is feeded into the generator that generates 7 to 8 megawatt capacity of the plant power. And photo B is a photograph representing gas turbine as a prime mover coupled to generator. Is It's just a coupling structure shown in the next picture, where you can see a generator and decoupled gas turbine. So the turbine is again having some compressor stages of 2 or 4 stages. So yeah, moving ahead, advantages. What are the advantages of gas turbine generator over others, and why to choose it? Because of course the prime mover is using gas. This size is already small, it weighs less, and the initial cost is very less. And when the plant itself is using its byproduct, then the initial cost reduces much below, which allows the profit margin to increase a lot. Hence it's easy to install within short periods. There is no or very less water consumption in this case. Also, it is very quick in starting and it is very smooth in running. So the wear and tear, the parts of damage or the corrosion problem as seen in other open plants is seen less over here. And also it is subjected to fewer environmental restrictions compared to other. Hence it is having a white lot advantages over other generators. So this is the end. Thank you for being patient and thank you for being extremely patient in my case. Any queries or any kind of
Yes, ma'am. Thank you so much, ma'am, to being here and share your time and knowledge with us. Thank you so much, ma'am.
thank you.
Sir, 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 am I audible to you, sir? Hello, sir. Ma'am, just give me a minute. Priya, ma'am.
Sure.
Hello, sir. Sir, hello, hello, sir. Student, anyone have a doubt? Anyone have a query? किसी को कोई पूछना हो तो आप पूछ सकते हो. Thank you so much, ma'am, being here with us.
Thank you, ma'am. Thank you, sir. Thank you, everyone, for being patient and for tolerating me.
Thank you so much, ma'am. So here we end our webinar session. Thank you so much, ma'am, to being here with us and share your time and knowledge with us. Thank you so much.
Thank you. Thanks a lot. Pleasure is mine.
Thank you so much.